Who better to ask for a guided tour than an astrophysicist who's been living here for a while? That's right, in a universe full of outrageous galaxies and superstar clusters, our solar system is just a tiny speck and we don't even realize it. There are thousands of stars within 100 light years, some so bright they're even seen from other galaxies, and some so dim they blend into the dark void. Hidden in spaces unknown, massive brown dwarfs and Earth-sized planets could even be teeming with life or pose a pesky threat. This just strikes my curiosity so bad because compared to our galaxy's 200 billion stars and a trillion planets, it's impossible to comprehend the entirety of this vast, diverse galaxy. So let's focus on the closest stars, a meager 50 stellar systems located within a 15 light-year radius, a place where celestial body formations is still going on. Let's strap our boots and take a trip to find fresh worlds. Won't be covering all 50, but I promise I'll show you the coolest ones around. Keep watching. Barnard Star. First stop, meet Barnard Star, the fourth closest star to Earth and coolest member of the Star Club. This red dwarf, located in the Ophiuchus constellation, is so small and low mass that it could give Jupiter a run for its money. It's also invisible to the naked eye, so grab your telescope if you want to get a glimpse. This star was named after American astronomer Edward Emerson Barnard, who noticed its proper motion way back in 1916. Barnard star is classified as a flare star of the By Draconis group, which means it still can party like it's a young star, even though it's twice as old as the Sun. By Draconis variables are stars that change how bright they look because of dark spots on them and how they spin. The time it takes for them to change in brightness is connected to how fast they spin. It's a slow rotator, taking a whopping 130.4 days to complete a spin, and it's lost a lot of its rotational energy over time. But don't count it out yet. This star is expected to stay on the main sequence for over 2 trillion years. Despite being such an oldie, Barnard star has shown astronomers that it still has a few surprises up its sleeve. It's been shown to experience flare events and exhibit low-level magnetic activity, which can make it a real star on the dance floor. While astronomers have been searching for planets around Barnard star for decades, it wasn't until 2018 that they announced the discovery of a super-Earth exoplanet, Barnard star B. Unfortunately, this planet isn't the life of the party, with an equilibrium temperature as low as minus 170 degrees Celsius. It's not exactly fit for life as we know it. Despite its small size and low mass, Barnard star is one of the biggest stars when it comes to proper motion, zipping across the sky at 10.358 seconds of arc per year relative to the Sun. So if you want to see this star's moves, you better keep a close eye on it. It goes fast, but not for Earth watchers, only for you. Sirius. Our next stop is the famous Sirius, known as the Dog Star, because it's part of the constellation Canis Major, which means the greater dog in Latin. And boy, is this pup bright. In fact, it's nearly twice as bright as its closest competitor, Canopus. Despite it being the brightest star in the night sky, you shouldn't worry. Sirius won't burn your retinas. Its distance of 8.6 light-years keeps it at a safe distance. Speaking of safety, did you know that Sirius is actually a binary star system? Yep, Sirius A and Sirius B are two stars that are kinda inseparable and stick together like glue. Sirius A is the star we see with the naked eye, while Sirius B is the faint companion star, also known as the pup. Sirius has quite the impressive resume. It's the brightest star in the night sky with a visual magnitude of minus 1.46, and it's even part of the winter hexagon, a group of stars that make a cool shape in the sky. Plus, it's a real crowd pleaser. From the southern hemisphere, Sirius is high in the sky, and from the mid-northern latitudes, it rises in the southeast, arcs across the southern sky, and sets in the southwest. But Sirius isn't all work and no play. It's got some cool mythological references too. The ancient Greeks believed that Sirius was responsible for extreme heat in midsummer, earning the expression dog days. And the ancient Egyptians based their calendar around the first sightings of Sirius in the eastern sky, which signified floodwaters that would bring new life. They even called Sirius the Nile Star. Scientists haven't found any planets near Sirius, maybe because the system is still young or the angle of orbit is different. There's a theory that says Sirius B used up all its energy and became a white dwarf, which wiped out any material that could have formed planets around the star system. Wolf 1061. Here's Wolf 1061. I bet very few of you have heard of this one before. But let's take a deep look at this cool red dwarf star 14 light years away from us. It's not as bright as our sun, but it's got a bunch of planets around it. 3 rocky exoplanets have been discovered, each with its own unique vibe. Let me introduce you. First, we have Wolf 1061b, the closest planet to the star. Unfortunately, it's too close, and the star's strong radiation makes it too hot for any living beings. What a bummer. But there's more. Next up in line is Wolf 1061c, the super cool super Earth. It's the perfect distance from the star and has a chance to support life. With a little more gravity than we're used to and a temperature a tad bit colder than your freezer, it's definitely a unique spot. But with the right atmosphere, liquid water may exist on its surface. That's dope. Plus, it's one of the closest exoplanets out there, ranking 5th on the list. Last but not least, let's check out Wolf 1061d. It's a bit of a weirdo with an odd orbit and a mass 7 times greater than Earth's. Its size could be anywhere from slightly larger than Earth to bigger than Neptune. But it's too far from the star to have any chance of life. However, it could teach us a lot about how planets evolve. Wolf 1061 is a super interesting place in terms of its position in the galaxy, right on the edge of a space cloud filled with super hot and super rarefied hydrogen. Who knows what we'll find next in this wacky star system? Let's keep going. Local interstellar cloud. Our solar system has been cruising through the local interstellar cloud for the past 10,000 years like a boss. This cloud is about 30 light years wide, but we're almost at the edge. Alpha Centauri is already living it up in the neighboring G cloud, but we're chilling here for another 2,000 years before we enter an even thinner and hotter region. Now let me tell you how this cloud was formed. 2 giant bubbles of hot cosmic gas collided and bam, the local interstellar cloud was born. It got its own momentum, magnetic field, and radiation, all perpendicular to our solar system's motion. But don't you worry, there's no need to panic. The solar winds got our backs against cosmic hydrogen, and our dense atmosphere takes care of particles that try to sneak in through the heliosphere. But get this, researchers found traces of isotope ion 60 and stellar iron in the ice of Antarctica. And guess where it came from? That's right, the local interstellar cloud. But don't be afraid, it's not harmful to us here on Earth. So let's just sit back, relax, and enjoy the ride through the local interstellar cloud. AP Columbae. As we continue our journey through space, we will soon get to a rather unusual star called AP Columbae, located 27.4 light years away from Earth. So as we are physically traveling forward, let's mentally travel back in time to 65 million years ago, when the dinosaurs met their doom and our primate ancestors were just starting to develop. Fast forward a bit and the Alps and Himalayas were born, thanks to the continents drifting apart. The world was a lot hotter back then, with the Arctic feeling more like the Amazon rainforest than frozen tundra. Meanwhile, just 27 light years away, a tiny red star called AP Columbae was getting its start in life. This little guy is only 1/3 the size of our sun, but it's still glowing strong and in its pre-main sequence phase. Thanks to an awesome international team of scientists from the University of California and the Australian National University, we've learned some cool stuff about AP Columbae. Scientists point out that we've known about this star for 15 years, but only now are we discovering its secrets. We use the parallax method to figure out how far AP Columbae is. But how the heck do we know how old it is? Well, when we analyzed the star's light, we found a funky amount of lithium. This super cool element was only produced during the Big Bang, and it lowers the ignition threshold for stars to start fusing. Long story short, if we see lithium in a star, it means the star is young and hasn't used up all its fuel yet. So what else do we know about AP Columbae? It's tiny, only 1,000th as bright as our Sun, and it has a surface temperature of 3,700 Kelvin. But the best part is it's super close to us, just 27 light-years away. This gives us a great opportunity to study how extrasolar planets, especially gas giants like Jupiter, form around other stars. The star is too young to have formed planets yet, but we have a lifetime to wait, and hopefully many more. Let's go to our next target. Gliese 370. Welcome to Gliese 370, an orange dwarf located a whopping 37 light-years away from our own planet. In 2011, scientists discovered a single exoplanet orbiting it, known as Gliese 370b. This little guy was spotted using the radial velocity method and has a mass of around 3 to 4 times that of Earth. Now, we all know that when it comes to celestial bodies, size really does matter. According to current scientific understanding, Gliese 370b is most likely a rocky planet with a radius about 30% larger than Earth's. This means the gravity on its surface could be at least 40% stronger than what we're used to. Talk about a workout. But don't worry, there's still plenty to be excited about. Gliese 370b is located right in the habitable zone of its star, only 0.26 astronomical units away. That means it completes a full rotation around its star in just 54.4 Earth days. And if its albedo value, that's how well it reflects sunlight, is similar to our own planets, then its average temperature should be around 25 degrees Celsius, a few degrees warmer than Earth's. Sounds like a pretty sweet spot for alien life to us. Of course, there's always a catch. Recent research has suggested that conditions on Gliese 370b's surface may be less hospitable than originally thought. But don't worry, we're not giving up on this planet just yet. It still holds great promise for the search for extraterrestrial life, and we'll keep exploring until we find out what this little planet is hiding. Castor. No, we're not done yet. Let's see what we have here. Picture it, or look at it. A glittering star system called Castor, with 6 dazzling stars, each one with their own unique personality. It was a real star-studded spectacle with 3 visual components and all of them being spectroscopic binaries. Although appearing as a single star to the naked eye, Castor was first discovered as a double star by James Pound way back in 1718. But rumor has it that Cassini may have spotted it as early as 1678, splitting it into at least 2 sources of light. Over time, the binary systems Castor A and Castor B began to drift away from each other, increasing their separation from about 2 inches in 1970 to 6 inches in 2017, with magnitudes of 1.9 and 3.0 respectively. Castor AA and BA were the dance partners with orbits of a few days, while Castor C, aka YY Geminorum, was discovered to have its own rhythm, varying in brightness with a regular period. It was known as an eclipsing binary, with additional variations due to areas of different brightness on the surface of one or both stars, as well as irregular flares. Castor A and B were like the Sirius kids at school, but oh so bright and with their own little red dwarf companions. They swirled around each other for 445 years, while the distant duo of red dwarfs hung out on the fringes, possibly feeling left out. I mean, can you imagine how cramped it must have been with all those stars in one neighborhood? The local bubble was a wild party zone full of thousands of stars and stuff formed by a string of supernova explosions. It was like a cosmic disco, pumping out X-rays and crazy energy, but don't worry, our magnetic fields and atmosphere had our back. And let's not forget the galaxies, these cliquey groups of stars and planets hanging out together like old pals. They form these massive, sprawling filaments that stretch for billions of light years. It was like a galactic block party with surprises around every corner. Who knows what kind of out-of-this-world shenanigans were waiting to be discovered? But the real star of the show was Castor itself, with its rich cultural history. Castor and Pollux were the OG twins, the stars that gave the Gemini constellation its name. Castor was even named after the son of Zeus and Leda in ancient Greek and Roman mythology. And let's not forget all the other names it went by, like Al-Ras, Al-Taum, Al-Muqaddim in Arabic, or Aul al-Jazira in the Catalogue of Stars in the Calendarium of Al-Aqs. It was like a global superstar, loved and admired by all. Pollux, Castor's twin. Back in 2006, some smarty-pants space folks discovered a ginormous planet orbiting the star Pollux. They used a fancy technique called the Doppler method to track the planet's gravitational wobbles. This planet, aka Beta Genorium b, is way bigger than Earth and hangs out in space farther away from Pollux than we do from the Sun. Astronomers were super jazzed about this find since it showed that planets can form around really big stars. And this was all before the Kepler Space Telescope got in on the planet-hunting action. Science is rad. Epsilon Eridani. Our second to last stop for this tour will be this one. Ran, also known as Epsilon Eridani, is a relatively young star located in the southern constellation of Eridanus, with an apparent magnitude of 3.73. It is the third closest individual star visible to the naked eye, situated at a distance of 10.5 light-years from the Sun. Epsilon Eridani exhibits a higher level of magnetic activity compared to the Sun due to its age, with a 30 times stronger stellar wind. Its equatorial rotation period is 11.2 days. This main sequence star has a lower level of elements heavier than helium and is smaller and less massive than the Sun. Epsilon Eridani is a potential member of the Ursa Major moving group of stars, which suggests that they share a common origin in an open cluster. Scientists using the Spitzer Space Telescope discovered that Epsilon Eridani has its own little solar system with rocky planets and gas giants. So far, it has a confirmed giant planet called Aegir. Sounds like a Viking god, right? And a debris disk that consists of a Kuiper Belt analog at 70 AU from the star and warm dust between about 3 AU and 20 AU from the star. The likely existence of outer planets in the system is suspected due to a gap in the debris disk between 20 and 70 AU. And you know who's probably psyched about this? Science fiction writers. Turns out Epsilon Eridani has been used as a backdrop for countless stories, shows, and movies featuring planets that are eerily similar to Earth. But let's not forget that sometimes reality likes to rain on our sci-fi parade, like when we found out that Mars isn't a glamorous oasis with canals and Venus isn't hiding a lush jungle behind its clouds. Oopsie. But luckily, Epsilon Eridani is looking pretty promising as a possible home for alien life, being so close to our own sun and all. And it's only 10.5 light-years away, which makes it a great candidate for interstellar space probes. I mean, come on, Babylon 5, Mr. Spock's home planet, and virtually all took place at Epsilon Eridani? That's gotta mean something, right? So fingers crossed that the sci-fi writers have got it right this time. But hey, who knows what we'll find when we finally send that probe out there. Luhman 16. Our last stop for this trip will be a rather unusual one. I thought it would be interesting to learn more about a brown dwarf not so far away from us, but it's like trying to find a needle in a haystack. Those sneaky little guys are just too dim for our fancy space gadgets to detect. But hey, that doesn't mean there isn't a whole bunch of rogue planets lurking in the space between us and our neighboring stars. I mean, who knows what kind of massive planets are out there just waiting to be discovered, am I right? But I digress. Let's talk about Luhman 16AB, the coolest, literally, brown dwarf duo around. These two are a real gem in our celestial backyard, and their planetary system in miniature could hold the secrets to the universe. So naturally, a bunch of smarty-pants scientists wanted to take a closer look and see what made these cool cats tick. Using some rad technology called TESS, Transiting Exoplanet Survey Satellite, they figured out that these brown dwarfs are just like Jupiter, banded and belted with high-speed winds running parallel to the equator. And get this, there's even crazy vortices swirling around the poles. It's like a giant cosmic storm party up there. Most of Luhman 16b is chilling out with its global wind patterns, just like our very own jet stream system. And those stripes you see? Thin clouds getting lit up by the hot interior, while the dark zones are thicker clouds blocking the light. It's all very fashionable, really. So while we're still on the hunt for that elusive brown dwarf, Luhman 16AB is giving us the best view yet into what these celestial oddballs are all about. And there you have it, folks. We've traveled through space and learned all about some of the coolest stars and planetary systems out there. From Sirius, the brightest star in the night sky, to Luhman 16AB, the coolest brown dwarf duo around. We've seen it all. We've explored the potential for alien life on Gliese 370b, discovered the secrets of Castor's 6 dazzling stars, and even traveled through the local interstellar cloud. But with so much left to explore, we can't help but wonder what other wonders of the universe are waiting to be discovered. So let's keep looking up at the stars and asking those big questions. Who knows what we'll find next?